So in this example, let's look at ASTM B152 code calculation for a copper plate. So ASTM stands for American Society for Testing and Materials, and they set certain standards that must be maintained when certain items are used in construction. This particular copper plate is cooled by air at 20 degrees C. The average convection heat transfer coefficient for the plate is to be calculated from the correlation for local heat transfer coefficient. We also want to determine whether the plate meets the ASME code for process piping. So here's a particular problem. The upper surface of a 1 meter by 1 meter ASTM B152 copper plate is being cooled by air at 20 degrees C. The air is flowing parallel over the plate surface at a velocity of 0.5 meters per second. The local convection heat transfer coefficient along the plate surface is correlated with the correlation according to the following formula, where H has units of watts meter squared Kelvin and X has units of meters. The maximum use temperature for the ASTM B152 copper plate is 260 degrees Celsius. We want to evaluate this situation and calculate the average convection heat transfer coefficient for the entire plate. If the rate of convection heat transfer from the plate surface is 700 watts, would the use of ASTM 152 plate be in compliance with the ASME code for process piping? So here's the solution. So we can calculate the average convection heat transfer coefficient for the entire plate by doing the following integral. In our case, L here is 1. So we integrate 1 over L, the integral of H times dx. We plug in our formula and do our integration. Plug in L as 1, and we calculate that H is 2.72 L to the minus 1/2. So if we plug in L as 1, that leaves 2.72 watts meter squared Kelvin. So from Newton's law of cooling, the convection heat transfer rate is given by the following formula. So solving this for the surface temperature T sub S, we can write the following equation. Plug in our known information. Q dot is, we're told to be 700 watts. We calculate what H is. The area of the plate is 1 meter by 1 meter, or 1 square meter. The temperature away from the plate is 20 degrees C, so if you calculate this, you get 277 degrees C. So here, obviously, if the average convection heat transfer coefficient is 2.72 watts meter squared Kelvin, that is not sufficient to cool the plate surface below the maximum use temperature of 260 degrees C for the ASTM B152 copper plate. Thus, the use of this plate is not in compliance with the ASME code for process piping.